Hello everybody and welcome to video 3 in the C++ tutorial for beginners. Now in this video, we're going to be talking about variables and data types. These are extremely important, and this is where we'll actually start learning something new, right? Because in the previous videos, I kind of just showed you the same thing again with more detailed explanation. Here, we're actually going to learn about how we can create variables, how we can store values, what the different types of variables mean, and very foundational and important topics we need to know about C++ or any typed language in general. So with that said, let's dive into the video. So the first thing that I'm going to start discussing here is something called data types. Now, data types are extremely important in any programming language, but especially important in a language like C++, which is statically and strongly typed. Now, to really understand why data types are important, we need to talk about variables, which we will do in a minute. But just like in math, in programming, we can have variables that store values. So, for example, we may have a variable called x. It may store the value 2. Now, if you saw an equation, something like 4x plus 2, you would probably be able to tell me that this equals 10 because you know the value of x is 2. Now, x is what we consider a variable in this algebraic equation, right? And it has the value 2. Now, the value that is stored by a variable has a certain type. In this case, this value is just a number, right? The type of this value is a number. We might call it an integer because it's a whole number. We might call it a floating point decimal if it had, say, something like 2.9 or a floating point number. You get the idea. Now, in programming, we have all these different data types. These data types are used in different ways, and they can be stored in a variable. So variables can store different types, and there's all kinds of different types in C++ and in any programming language. Now, the 5 main data types I want to show you right here are the kind of foundational, really important ones in C++, and they are the following. We have an int, we have a float, we have a bool, we have a string, and, we have a character or a char. These are the 5 most important data types that you need to understand in C++. Now, again, when I'm saying data type, I'm really just talking about the type of data, the type of information that something may store or that we may use. Now, an int stands for integer, and an int is any whole number that does not contain a decimal. So it doesn't matter whether it's positive, negative, or 0. Any whole number that does not contain a decimal point in it is an int. So the number 7 is an int. The number 98 is an int. The number -9 is an int. The number -975765 is an int. 0 is an int, and so on and so forth. 10 is an int. You get the idea. So anything that does not contain a decimal is an int. Now, a float is very similar to an int, but it's any number that contains a decimal point, contains a level of precision. So if I have something like 7.0, even though this number theoretically in math is an integer because it's a whole number, it is actually considered a float in our programmer in C++ because it has this decimal point right here. And decimals are treated much differently in our program. The way that binary represents them and everything like that is just a lot different than an integer. And so that is why they are considered floats. So something like -9.8 is a float. Something like 0.2 is a float. Something like 2.1 is a float. Whenever you have a decimal, doesn't matter what that decimal value is, as soon as you see a period and it is attached to a number, then you know that you have a floating point value, or you have this data, which is considered a float. So that is the difference between int and float. Really get that into your brain. Make sure you memorize that because you need to understand the difference. Next, we move on to Boolean. Now, bool or Boolean, bool is the short form for Boolean, stands for true. And I actually believe this is lowercase, and false. So Boolean value can be one of two things. It can be true or it can be false. Now, this is just like in binary where you can have a 1 standing for true, or you can have a 0 standing for false. So these are Boolean values. We're going to use these later on in the tutorial series, but they're very important. And just understand that a bool or a Boolean is either true or false. It's one of these two values, nothing else. And it must be with a lowercase. So as soon as I go like this is not a Boolean. This is actually nothing. This is not a data type because it does not have the lowercase t. But now when I put the lowercase t, this becomes true. So capitalization is very important in programming. Make sure you understand that as well. Int right here, that's highlighting in kind of this turquoisey color, is not the same as int with a capital I. They are very different. All right, so now we move on to string. Now, string is actually a type that we need to import, or not import, we need to include in our program. So a string is simply anything that is surrounded by double quotation marks. Anything inside of double quotation marks, doesn't matter what it is a string. So if I do h, this is a string. If I do 7.0, this is a string. The reason it's a string is because it's surrounded by double quotation marks. Even though 7.0, technically speaking, is a float, right? We can see 7.0 right here under float. Since it is surrounded with double quotation marks, that makes it a string. Now we could have 7.0 hello, we could have a bunch of random characters. Any character on the keyboard we can type, if it's inside of double quotation marks, it is a string. A string can be any length, a string could be 0 length like this, a string could have a ton of spaces inside of it, it could have, brackets, whatever. Anything in double quotation marks is a string. Now a character is any single character on your keyboard. Doesn't have to be numeric or alphanumeric. It can be a special character as well that is inside of single quotation marks. This is the differentiator between a string and a char. Char again standing for character. So X, this is a character. 0, this is a character because it's inside of single quotation marks. This is not valid because this is 2 characters inside of single quotation marks. You cannot have that. You have to have only 1 inside of single quotation marks to represent a character. Now, if you have double quotation marks and you have 1 single character here, this is still a string because it's inside of double quotation marks, okay? Now, as soon as you switch that into single quotation marks, this becomes a char or a character. So there you go. Those are the main data types. Memorize what they are. Make sure you understand what they mean because they're extremely, extremely important. I cannot emphasize that enough. Now, the next thing I'm going to show you here is just something to do with string. So this string data type you're going to use all the time. It's very important. However, it is not built in to C#. What am I talking about? It is not built in to C++ by default. What I mean is we must include the library that contains string into our program to use this string data type. So what I'm going to do is copy this first line right here, and I'm going to put include string like that. What this is going to do is include the string library into this program. This now means when we define something as a string, this will actually work. If you don't include string and then you try to use this string data type, you will have an error because you cannot find string. You won't be able to find a reference to it. And also notice that string is not highlighting in this turquoise color like these other data types are. So those are our main data types. And this is a good point in time for me to talk to you about something called comments because I'm going to comment these out. So obviously this is not valid code. What I have right here, I can't just write this. This is just me trying to illustrate what the data types are. So whenever you have something that you don't want your compiler or your C++ program to actually read, but you want to have in your code, maybe for reference for yourself or for someone else to read, you can create something called a comment. Now a comment is anything preceded by 2 forward slashes. So if you have 2 forward slashes, anything you type on this line is considered a comment. It will be ignored by your program. It is simply here to help you, the developer, you, the programmer, understand the program, write something down. It's just anything that you would like to ignore. So this is what's known as a single line comment. As soon as I start typing below this, notice it no longer highlights in gray. This is no longer a comment. This will be interpreted by the compiler. Now that is a single line comment. A multi-line comment is the following. You have a forward slash and an asterisk, and then an asterisk and another forward slash, and this is a multi-line comment. Anything between these 2 lines will highlight in gray and will be ignored by the compiler. So there's a single line comment and a multi-line comment. Usually you use single line comments. However, if you have multiple lines you would like to comment out, you use a single line comment. Or sorry, what am I saying? A multi-line comment, which is this. Okay, so there you go. Hopefully that is clear. Again, this is multi-line. You must have a terminator for it. If you don't have a terminator, you're going to have a crash in your program. And then this is a single line comment like that. Okay, so what I was going to do, I actually had it in the multi-line comment, was I was just going to leave these data types commented out in this multi-line comment at the bottom of my program just so it's ignored by my compiler and you guys can still read. So we will continue in 1 second, but I need to quickly thank the sponsor of this video and this series, which is AlgoExpert. AlgoExpert is the best platform to use when preparing for your software engineering coding interviews. They have over 140 coding interview questions on the platform, and I actually happen to work there as an algorithms instructor. So with that said, check out AlgoExpert from the link in the description and use the discount code TechWithTim for a discount on the platform. So now that we understand data types, let's talk about variables. Now, variables are extremely important. They're very versatile and they're used all over the place, not just in programming. Like I was saying before, you could have a variable in math, maybe x equals 2, and then, substitute that into an equation or something. And whenever you reference x, it's going to give you the value 2. Now, in programming, it's very similar. There's many different ways to define a variable, but just think of a variable as some name to store some value, some way to access some information. You access the variable, it gives you that information. You can also modify variables, you can add variables, you can change them, you can assign variables to other variables. Very versatile, you can do a lot with variables. Now, to define a variable, as I said, there's a few different ways. The first way to do this is to define the type of the variable, define the variable name, put an equal sign, which stands for an assignment operator. So the equal sign is the assignment operator, and then put some value here that is the type of the variable you defined and store it in that variable. So when I write this line, this is saying I am defining a variable called x. It is of type int, is an integer. This means x may only hold integers, and x is going to be assigned to the value 2. So now what I can do is I can actually see out x. So see out, and then I'll do my, what is this, stream insertion operator. And then if I run this, you will see that 2 will print out to the screen. So the idea being, again, we defined that the type of the variable is an int, is called x, it is equal to 2. Let's now characters output x. Okay, so let's run this. If I go G++, and now I do run program, notice 2 print to the screen. There we go. That is the basics of variables. So when you define a variable, it's very important that the value you store in the variable is the same type as the variable you defined. Now, let me actually just show you what happens if I assign a type to this variable that is not the correct type. So let's do this. Let's actually assign x equal to a string. So this is a string because it's in double quotation marks. The type of the variable x is an int. And let's see what happens when we compile this program. So when we compile this program, we get an error. It says invalid conversion from const char to int. It says int x equals string, and this is where the problem is. So you don't have to worry about what this error message is really. It's just kind of telling us that we cannot assign a string to an int because this variable is of type int. However, if I now try to do something like 2.7 and I assign that to x, let's see what happens. So when I do this, notice that the program actually compiles fine. And now when I run the program though, notice that we get 2 printing out, not 2.7. This is not me running a previous iteration of the compilation. This is what happens when you assign a value that is not an integer to an integer variable. What will happen is C++ will try to convert this value here into an integer. So whenever you try to assign a value to a variable that is not the correct type, it will try to convert that variable, or sorry, not that variable, that value into the correct type. So in this case, to convert a float to an int, you simply chop off the floating point part. So you remove the decimal, and there you go, you get the int2. To show you another example, if we did 4.7 and we run this now, and then we run program, we get 4, right? It just chops off the decimal point. So that is kind of some errors you may run into if you try to assign values to a variable that are not the correct type. That is the first way to define a variable. Now, of course, we can define other types of variables as well. We can say string, we can say y, and then we can make this equal to, say, Tim. So now let's see out y, and let's see what happens. So G++, run our program, and then Tim prints out to the screen, no problem. Don't worry that this isn't highlighting. It's just because it's from the library. It's not like built in by default into your standard C++ coding environment or whatever you may call it. So there you go. That's another variable. So when you create variables, there are a few rules that you need to keep in mind, and these are specific to the naming of your variables. So when you name a variable, you want to make sure that this name is unique. So if I'm defining a new variable that I have not created before, the name of this variable must be unique. What that means is that I cannot redefine a variable I've already created. So if I have something like int x equals 4.7, I create the variable x and I store 4.7 inside of it. Now, if I try to say string x equals Tim, let's just see out x here so we don't get that error. Let's see what happens. Let me clear the screen. Let's run this. Notice we get an error. It says that there was a previous declaration as int x, so we now cannot define this variable name as x because it was defined before. Now, that's just one of the rules, but there's a few more rules as well. Another rule is that your variable names may not contain any special characters other than underscores. So you cannot contain spaces, you cannot contain asterisks, you cannot contain ampersands, anything like that. The only special character you're allowed is an underscore. Other than that, you may contain letters and numbers. They may be uppercase letters if you would like, but you cannot start your variable name with a number. So I cannot have a variable called 1y. If I try to do this, the compiler is going to yell at me, and it's going to tell me that I cannot do that. Just not allowed, okay? But however, I can put a 1 at the end of the variable name. So I could say something like y1. So now let's try this. Let's see if the compiler yells at me. It does not. I can run the program. Everything still works. Now you can contain numbers in the middle of your variable name as well. I could say like y1s, right? And that is totally fine. That is valid. You just cannot start with a number. Now, a lot of times when you're creating variables, you want to make sure that your variable name is descriptive. So whatever your variable is holding, you want to have the name actually be descriptive. So a variable name like x is not very descriptive. Maybe it works in this case because we're just holding a number. But in this case, if I'm holding like my name in a variable, I would want to call my variable name. just so that it makes sense. Anyone else reading my program knows what this variable is holding, because you have to remember, as a programmer, a lot of times you're not the only person reading or using the code that you wrote. So just keep that in mind. Try to name your variables something relatively descriptive. And the point of me saying that is a lot of times when you try to do this, name them something descriptive, you're going to realize that you need kind of multiple words to describe what your variable is holding. If that's the situation, what you want to do is the following. You want to use an underscore to act as a space. So you could say something like name Tim, like that. And then this would actually separate the variable, right, into kind of two separate words. And since you can't use a space, use an underscore instead. Now, traditionally in C++, it is better practice to use something called camel case to do something like this. So if I wanted to say name of user, I would type it like this rather than typing it with underscores. So name underscore of, underscore user. So this is the preferred way when you use camel case rather than what this is called, which is snake case. Now you can use whatever you want. You're not writing any production level code. It doesn't really matter at this point, but just figured I would mention that to you. The kind of standard way for using multiple words is to have camel case. So that is the first way you define variables. You do the type, name of variable, equal, and then what is equal to. Although sometimes you would like to create a variable, but you do not want to initialize it. When I say initialize it, I mean assign a value to it immediately. In that instance, what you can do is type the following. You can type the type of the variable, then the variable name. So in this case, I can say int x. Now what I've done is I've created the variable x, but I have not assigned any value to it, or I have not really initialized the variable. What I can do now, though, since I've defined the type of this variable, is I can assign something to it without having to rewrite the type. So I can now say something like x equals 7, and then I can cout x, and this will totally work. So let's do this. Let's compile our program. And what is it saying? Expected a semicolon. Where was it expecting the semicolon? I realized that when I couted x here, I made a mistake. I needed to add my stream insertion operator. So let's now try this, and we should see that this works. That was the error that I was getting. Okay, compiles fine. Now we run, and we get 7 printing out to the screen. So this is a way to define a variable. Kind of a little trick here. If you want to define multiple variables, but you don't want to assign anything to them, you can say x, comma, y. You can do the type beforehand. And now you've created two variables that are both type int, one called x, one called y. I assigned a value to x. I have not yet assigned anything to y. If I compile this program, you'll see that this does work, and we don't get any errors. That's totally fine. And you can also change the value of a variable once it has been initialized or once it has been created. So now I could say something like x equals 6, and then maybe I'll say something like x equals 8. And now what's going to print out? Well, it's going to be 8. So let's have a look here. And we see that we get, trying to get to the run program, we get 8 because at the point when we printed out the value of 8, it had been changed, or not 8, of x, it had been changed to 8. So hopefully that's clear, but that is kind of the very basics on variables. There's a few other ways you can create variables, but these two ways are the standard ways. You can also have variables interact with each other. So let's say I define y equals, and I make this equal to something like 4. What I can do now is I can cout x, and then right after, I can cout y. So let's have a look at these right here. Let's compile the program. Let's run it. Oops, I accidentally compiled it again. Let's run it, and we get 8, 4. Now we're not getting 84, we're getting 8, 4, but they're just being kind of mushed together because we don't have a space in between. That's fine, but now let's see what happens if I do this. X equals y, and let's just cout x now. Take a guess, what do you think is going to print out? Let's compile the program. Let's run the program, and we got 4. The reason we got 4 is because we changed the value of x to whatever y is equal to, which in this case is 4. So that is kind of the way that variables work. Just keep in mind you can change the value of variables, but the value you change them to must be the same type as that variable. So again, when you define the variable, type, name, equals assignment, or you just do type name, and then you can assign something to that variable or use it without having to redefine the type. So I think that's pretty much all I need to show you about variables. Just keep in mind the data types are very important. You must assign the correct type to a variable. If you try to assign a type to a variable that is not the type of that variable, C++ will try to convert that variable, or convert that value, to the correct type. And it can do that for a lot of instances, but in some instances it cannot. So you may get weird, strange errors, and that may be because you're trying to assign a value to a variable that is not the correct type. So with that said, that is going to conclude this video. I hope that this was helpful, and I look forward to seeing you in another C++ tutorial video.